Hey everyone, so this is our math for the week of April 6th. This week we'll be looking at categories of two-dimensional figures, mainly looking at sessions 1, 2, and 3. I know on Monday you have the iReady assignments, so maybe you can look at this either on Monday or Tuesday. This will carry through sessions 1, 2, and 3, like I said, and I based this video completely off the textbook, so it may not have all of the examples on it about the textbook, but it definitely covers all the material. So if you have any questions or doubts about stuff that you saw in textbook for this week, you can definitely refer to this video and it should clear anything up if you have any questions, okay? So first, when we're looking at these two-dimensional figures, we have to look at the word polygon. A polygon is a shape that has at least 3 sides and angles, okay? We can categorize or group them based on their attributes or features, okay? So when we're looking at these polygons, let's see, there's definitely one of these that is not a polygon. If you can identify it, think about that. Yeah, so this circle is not a polygon. Why? Why is the circle not a polygon? Well, answer the question. Is it a shape? Yes, it is a shape. Okay. Does it have at least 3 sides and angles? That's where this circle is not a polygon. It has one side, and it's one continuous side. It doesn't have any angles, so we can't say this circle is actually a polygon. So we're going to kind of just forget about this right now. We're going to be looking at these other shapes. We can categorize these polygons. Let's say if I want you to categorize polygons that have, let's say 4 sides. Looking at these pictures, not including our circle, can we think about shapes that have 4 sides? Yeah, of course we can. We can look at the square, we can look at the rectangle, we can look at the diamond, and we can look at the trapezoid. Those all have 4 sides, so if we were to group them, we can group those all together. They'd be under one group of 4-sided shapes. Now if we say I'm looking for objects that have a right angle, okay? Maybe I would look at this right triangle right here. I would look at the rectangle, and I would look at the square. See, so we can change around what categories we want to use based on our necessity. So let's keep on looking at this. In order to categorize these different polygons, these different shapes, we're going to be using Venn diagrams, okay? A Venn diagram is using shapes like ovals we see here to compare and contrast different categories. And we can use these to classify different shapes in a hierarchy or a ranking based on their attributes. So we can look down here, this Venn diagram that I have over here, it gives us quadrilaterals. Quad meaning 4, lateral meaning side. So 4-sided figures, okay? So basically we're saying quadrilaterals under that general topic includes trapezoids, parallelograms, rectangles, squares, and rhombuses. All of those 5 things fall under the category of quadrilaterals. Now, in its own little category over here, we have trapezoids because they may not fall under this category. When we go into this red circle, we see parallelograms. Okay, a parallelogram is a shape that has parallel sides. Okay, so within parallelograms, we have rectangles, squares, and rhombuses. Then we know, looking at our Venn diagram here, that rectangles, squares, and rhombuses all have parallel sides. And not only do they all have parallel sides, but they all have 4 sides because they are all quadrilaterals. So I have over here, we said, for example, all squares, rectangles, and rhombuses are parallelograms. But it's important to note that not all parallelograms are squares, rectangles, or rhombuses. And that's how we can kind of learn to read these Venn diagrams. Okay, let's look at one example in specific. So we have a rhombus and we have a square. 2 shapes that look rather similar. Okay, for a rhombus, they have all 4 sides of equal length. 1, 2, 3, 4. Okay, they all have equal length. they have two pairs of parallel sides. This and this are parallel, as well as this and this are parallel, okay? And they have four angles. For the rhombus, it does not say if it has to be an acute angle, an obtuse angle, a right angle. It's just four angles in general. If we could look at a square, all four sides of equal length, okay, that's the same. Two pairs of parallel sides, okay, that's the same. Four right angles, whoa, okay, so four right angles, that makes a difference in a square. So, if we look and try to make a Venn diagram for a square and a rhombus, we can say that the difference between a square and a rhombus is that a square's angles are specific and classified as right angles. So, looking at this, all squares are rhombuses, but not all rhombuses are squares. Can we see that? We can see how this square inside is inside the rhombus because we're literally showing this Venn diagram with using the physical shapes. All squares are rhombuses, but not all rhombuses are squares. Okay, let's keep going. That's the end of session 1. If you're doing your work day by day, this will be end of your work for Tuesday. I'm going to continue the video, and that will go into session 2 and session 3. So this is from our book, the beginning of session 2. This is what we look at. This is kind of our larger Venn diagram. Okay, it describes, we're trying to put rectangles, squares, and parallelograms into this giant Venn diagram, okay, to try and go from the most general to most specific. So we have quadrilaterals. We said earlier quadrilaterals have four sides. We get more specific. Two pairs of parallel sides. What's the most general of a rectangle, square, and parallelogram that has two pairs of parallel sides? Right, parallelograms. Then, if we go a little more specific, four right angles. Now, it doesn't say about the length of the sides, just says four right angles. So, when we're thinking about that, we can think the rectangle. And that leaves us in the end with our square. So, if we're breaking it down, we can say all squares are quadrilaterals. All squares are parallelograms. But we cannot say that all parallelograms are squares. We cannot say that all rectangles are squares. Okay? Can we see how we can go from getting more general to more specific? In a similar way to a Venn diagram, we can use tree diagrams in like a chart form to connect elements to show the relation. Okay? We think about like a tree kind of because it's like branches. We still have the most general up here, and we go down to the more specific. So you can kind of see how similar it is. I'm going to go back to the previous slide. General, specific, specific, specific. General on top, and then we go more specific, specific. Okay, and that's how they organize it. At the top is the most general, the biggest part of it, and then as we get to the bottom, we get more and more specific. So, reading this tree diagram, we can see that all squares are rhombuses, all rhombuses are parallelograms. That means that all squares and all rhombuses are parallelograms. But that does not mean that all parallelograms are rhombuses, does not mean that all parallelograms are squares. Most general, more specific. Okay, so we're going to keep on building this tree diagram. Let's start with quadrilaterals. We have a four-sided object. They're four-sided, that's it. We get more specific. Parallelograms. A four-sided figure with two pairs of parallel sides. We saw this earlier. We get more specific from there. Rectangles, a four-sided figure with two pairs of parallel sides and four right angles. And we get more specific from there. Squares, a four-sided figure with two sets of parallel sides of equal lengths and four right angles. So if you kind of follow the path, you can see, and I did this on purpose so you can see how the definition builds. A four-sided figure, that's a quadrilateral. Quad, four, lateral, side. A four-sided figure, quadrilateral. Okay? It's super general. It's a very simple definition. As we keep on moving on and on and on, we get more specific. And I kept the same definition base just so you can see how it builds and it gets more and more specific as you move further down this tree diagram. I did the same thing here, and I did kind of like I did in session 1, and I used the actual shape so you could see it one with another with another. If we were to say polygons in general, we know polygons from earlier in session 1. We saw polygons were shapes that have at least 3 sides and angles. We'll use the example of a pentagon. Okay, pentagon, a 1, 2, 3, 4, 5-sided figure. Pentagon is a polygon. Again, this is just an example. Then we get more specific. Triangles. Okay, and we get more specific from there. Isosceles triangle. Then if we're going to try and make a statement out of this, if we want to try and describe the shapes and describe the relation, what can we say? Think about it for a second. When we think about it, we can say that all isosceles triangles are triangles. All isosceles triangles are polygons. All triangles are polygons. Remember, I'm using pentagon here as an example because polygon is not one shape, but it can be many different shapes. Okay, but we cannot say that all polygons are isosceles triangles because then we're saying something so general is always something so specific. Okay, that's a good way to kind of think about it. Something so general is always something specific, whereas something specific could be something more general. Okay. And this is really the main thing in session 3. Session 3 is a little bit shorter, but it goes into the idea that if a polygon is called regular, all of the sides are the same length. Now regular here, we would think regular, we think something that's normal. We can think of them in its most natural state. If a polygon is regular, all the sides are the same length. So these are some common regular polygons. We have a pentagon, we have a square, we have a triangle, we have a 12-sided polygon. Okay? All of the sides within each shape, all of them are equal sides. So we can say they are regular polygons. A regular pentagon, a regular square, an equilateral regular triangle, and a 12-sided regular polygon. Okay? Hopefully, this video was able to help with sessions 1, 2, and 3 with your work, and see you guys next week.